We trust our senses to tell us about the world. We see, hear, touch, smell, and taste. Our brains then take this sensory information and construct our reality. But what if I told you that this reality is often a grand illusion? Our brains are masters of deception. They take shortcuts, fill in gaps, and make assumptions. This isn't always a bad thing. These shortcuts help us navigate a complex world. However, sometimes these shortcuts lead to fascinating errors in perception. We call them illusions. Illusions reveal the hidden workings of our brains. By studying them, we can learn how our brains process information. In a way, illusions are like windows into the mind. They show us how our brains construct the experience of reality. Prepare to be amazed as we explore the world of illusions. We will see how our brains deceive us, and in doing so, we will uncover the secrets of perception. Our eyes are bombarded with a constant stream of light. This light is then processed by our brains to create the images we see. But this process is not always perfect. Our brains can be fooled, and optical illusions exploit these weaknesses. Take, for example, the Muller-Lyer illusion. Both lines are the same length. However, the line with outward-pointing arrows appears longer. This is because our brains interpret the arrows as depth cues, making one line seem farther away and therefore longer. Another classic example is the checker shadow illusion. The squares marked A and B are the same shade of gray. However, our brains perceive square B as lighter because it's in shadow. Our brains automatically adjust for shadows, assuming that objects in shadow are lighter than they appear. These illusions demonstrate that our brains don't passively record the world. They actively interpret it, using context and prior knowledge to make sense of what we see. Illusions aren't limited to our sense of sight. Our other senses, and even our thoughts, can be tricked as well. These are known as cognitive illusions. They highlight the fascinating interplay between perception, attention, and memory. One famous example is the Stroop effect. Try to say the color of the ink, not the word itself. You likely experienced a delay or even said the wrong word. This is because reading is an automatic process, while naming colors requires more effort. The conflict between these two processes creates interference. Another intriguing illusion is change blindness. We often miss large changes in our visual field if we are not directly attending to them. This is because our brains prioritize attention on what we deem important, filtering out extraneous information. These cognitive illusions reveal the limitations of our attention and the constructive nature of our memory. They show that we don't always perceive the world accurately, rather we see what we expect to see and what our brains deem important. Our ears are constantly bombarded with sound waves, vibrations that our brains interpret as sound. Just like with vision, our brains can be tricked when processing these auditory signals. The Shepard tone is a fascinating example of an auditory illusion. It creates the illusion of a continuously ascending or descending tone, even though the pitch remains constant. This is achieved by playing overlapping tones that fade in and out, creating a perpetual sense of motion. Another intriguing auditory illusion is the McGurk effect. This illusion demonstrates the powerful interaction between hearing and vision. When we see a person's lips move in a way that doesn't match the sound we hear, our brains combine the visual and auditory information to create a third, blended sound. These auditory illusions demonstrate that our brains don't just passively receive sound. They actively interpret it, using context, expectations, and even other senses to construct our auditory reality. Even our sense of touch, the feeling of pressure, temperature, and pain, is not immune to illusions. These tactile illusions can be incredibly vivid and even challenge our understanding of our own bodies. One striking example is the rubber hand illusion. This illusion works by creating a conflict between what we see and what we feel. The synchronous stroking leads the brain to integrate the rubber hand into the body schema, creating the illusion of ownership. Another powerful example is the experience of phantom limb sensations. Amputees often report feeling sensations, sometimes even pain, in their missing limbs. This is because the brain retains a map of the missing limb, and even though the limb is gone, the brain can still generate sensations in that area. These tactile illusions demonstrate that our sense of touch is not just about physical stimulation. It's also about how our brains interpret and represent our bodies in space. Even the laws of physics, the fundamental rules governing the universe, can be manipulated to create illusions. These illusions showcase the fascinating interplay between light, perception, and the brain's interpretation of the world. One classic example is the illusion of refraction. When light passes from one medium to another, like from air to water, it changes speed and direction. This bending of light, known as refraction, can create the illusion that objects submerged in water are broken or distorted. Another fascinating example is the mirage. Mirages occur in hot conditions when the air near the ground is much hotter than the air above. This temperature difference causes light to bend, creating a shimmering image that resembles a reflection of the sky. Our brains, accustomed to seeing reflections on water, interpret this as a pool of water, even though it doesn't exist. These examples demonstrate that even the seemingly objective laws of physics can be manipulated to create illusions. Our brains, constantly striving to make sense of the world, interpret these visual cues based on our prior experiences, leading to fascinating and sometimes deceptive perceptions. We have journeyed through a world of illusions, from tricking our eyes with lines and shadows to experiencing phantom limbs and hearing phantom sounds. We have seen how easily our brains can be deceived, how our perception of reality is a fragile construct, molded by our senses, experiences, and expectations. This begs the question, what is real? If our senses can be fooled, if our brains can conjure up illusions so convincing that we question our own bodies, then how can we be sure of anything we perceive? Perhaps the world we experience is just an elaborate illusion, a grand simulation constructed by our brains. Or maybe these illusions are not flaws in our perception, but rather features, essential tools that allow us to navigate a complex and ever-changing world. Ultimately, the answer to this question remains elusive. But one thing is certain: the study of illusions provides a fascinating and humbling glimpse into the hidden workings of the human mind and its remarkable ability to create meaning from the world around us.